Hello everybody, my name is Roy and I'm from Dexcom, and with me is...
I'm Dan, and I've been with Dexcom for about 7 years from a database engineering background, and most recently started working with Roy in analytics.
I've been with Dexcom about 5 years and do a lot of analytics, not only in the manufacturing space. Dan's primarily comes from the manufacturing background. I work on different data elements such as finance and otherwise. I do have a love for manufacturing though, as in previous lives I worked on manufacturing type software. So manufacturing is definitely a sweet spot for me, and obviously it is for Dan as well. I reside from Colorado Springs, working remotely.
And I'm in San Diego, so you're gonna have to bear with us. We're data engineers, not professional speakers. So we're gonna get into some details, but I guess, go ahead.
Yeah, go ahead and hit the next slide. So it's a little bit about who we are as people, but Dexcom, what are we? So continuous glucose monitor. This is it on my arm here. The quick story is every couple of minutes, about every 5 minutes, the device, a wearable device, transmits by way of Bluetooth the glucose value over to your phone. I've been a user of the Dexcom product, being a type 1 diabetic, for many more years than I've been an employee. So definitely have a lot of pride in my work, and pride in the product and making it as good as it can be. We serve initially type 1 diabetics, such as myself, and then more recently targeting the type 2 diabetes demographic, and then most recently as a wearable for anyone and everyone. So like professional cyclists are wearing our newest product called the Stello to monitor their glucose as they're doing their activity. If someone is interested in how their glucose goes up, goes down as they are intaking food or exercising. It's a wearable kind of similar to like a smartwatch. This thing can tell me my steps, my heart rate, etc. Just consider glucose value as being another data point that can measure your body. We are an employee of 10,000 plus, we are a company of 10,000 plus employees, founded in '99, $4 billion revenue company, and we have 15 plus manufacturing / contract manufacturing locations across the world. For us specifically in manufacturing plants that we own, there's San Diego, where our company headquarters is, Mesa, Arizona, and then there's Malaysia, and then soon in construction right now is Ireland. And obviously we have lots of contract manufacturers that feed supplies and feed product into each of these manufacturing sites as well.
So obviously Dexcom is a huge company. There's tons of data teams, tons of different types of data. This presentation is mainly focused on global and manufacturing data specifically. So we're going to be going over the journey that we went through as a global manufacturing data team in modernizing our data analytics environment. So just to set the stage for what our environment looks like, it's a 24/7 manufacturing environment. Round-the-clock data is being added to our database, and this is a two-way interaction with our databases. We produce about 100 million devices per year, and each of those devices it generates about 800 to 1,000 rows of data per device. So, and all of this data is captured in SQL Server operational databases, about 750 tables total across all the sites where we're gathering the data, and that equates to about 80 billion rows of data per year, and that's also continually ramping up as we ramp up production. So, why is data analytics critical in manufacturing? I've worked in many different environments. Manufacturing is a very different mindset. The emphasis is on the process and producing product, getting product out the door. That's how we make money, is selling product. So a lot of times the software and the data systems can kind of take a back seat to just getting product out the door. But we are beginning to realize how valuable that data is. We have many different teams. There's a process engineering team that is constantly looking at what's going on the floor. They're looking at operational efficiency, yield. They're trying to find drift and process. Anything in the data that might tell them why we're losing product quality, why we're having to scrap product. So they have a need for real-time data, and we have teams that serve up dashboards, executive reporting, daily inventory management, all kinds of teams that want the data. And then there is a real need for conformity across all of our sites. We have sites all across the world. They're 8 hours apart now because we have San Diego, Penang is 16 hours ahead, and then soon to be Ireland is going to be 8 hours ahead, so 24/7 globally. And we want to be able to, when we find a problem or a data issue or something with the data that lets us know of an issue at one site, we want to be able to share that with all the other sites. So there's a need for conformity in our analytics environment. So just to give you an idea where we came from, I'm going to kind of go over quickly the initial analytics environment that we came up with. We were a team of SQL Server experts, so of course we decided to build a dimensional data warehouse in SQL Server. And we had two kind of forms of that data warehouse. There was one that was just a traditional fact and dimension data warehouse, and then the one that was just replicated operational tables that were optimized for write operations, and we just put views and functions over the top of them, and that did not scale well. Neither of those scaled well. The first one did not scale well because just the complexity of dealing with SSIS. I come from an SSIS background, and the project that supported this analytical warehouse was very large. I built most of it, and actually I struggled to understand my own code after a while, just with how much was going on with parent packages, child packages, et cetera, let alone trying to bring in somebody new into that. So it moved very slowly. And then with the views on top of replicated tables, those tables were designed to scale with writes, but not with reads. So that did not scale very well either. They quickly became very slow. Then there was the problems with visibility. If you wanted to know where a piece of data came from, you had to open up views, functions, packages, really dig into it. You had to be kind of a developer to understand where the data came from. So that was kind of a problem. And then there was the issue of just conformity. We kind of grew organically, and when we launched Malaysia, they kind of developed their own data warehouse solution. So they solved some problems, we solved problems, but if anybody wanted to see a global view, that became very hard to reconcile all of the differences. So out of this, we kind of saw the need to modernize our environment.
All right, so that's a landscape of the analytics environment, as Dan described there, of what once was on-premise in each of the manufacturing locations. So let's talk about our cloud implementation here and different tools involved. So we have a little bit of a complicated mess using 3 different tools to do the E and L of our ELT. We're using Kafka/Debezium as our open source, and a separate team within Dexcom is accomplishing those duties and all that monitoring and the streaming in of the data for us. We, like most of you likely, are using Fivetran to load in some of our data. And then also, most recently, we've started leveraging inside the GCP platform data stream as well. So those 3 together are extracting the raw data that is monitoring the CDC logs of the on-premise MS SQL tables, and it is loading it up into Google BigQuery tables. So as Dan mentioned, hundreds and hundreds of tables that are being replicated across or streaming into BigQuery, and then obviously dbt is our transformation tool of choice. And after the data is transformed, it's available. As many of you know, there's lots of different folks who have lots of different tool preferences for how to consume the data. Probably a crowd favorite might be Tableau, and we can't be up here without saying the words AI. So there's some interest in AI, of course, and AI tools pulling from the data. There's a little bit of Power BI dashboards. Again, 10,000 plus employees, so there's going to be a little bit of a sprawl of tools, but we're here to accomplish what needs to be accomplished. So kind of a little bit of the same picture, but a left to right view here and a little bit different type of detail. Again, on the left, there's data sources. There's Microsoft SQL Server. We're moving the data across onto the cloud using those 3 tools. And then let's pause here a little bit on the data platform. So we are a GCP shop, which therefore means Google BigQuery as our table. We have a couple of different GCP projects and the tables that sit within, and then on top of that, DBT projects. So first, there's the ingest/landing zone. That's where raw data will sit, untransformed. That Fivetran, Kafka Debezium, and DataStream will push data, merge data into the GCP tables, the BigQuery tables within GCP in the ingest/landing zone. And then think of your classic staging environment with DBT. We're doing that by way of a curate layer, we're calling it. So in the staging, it's your classic transformations, no joins, casting data types as we see fit. Each of the 3 tools that we're using to extract and load in data has some, not necessarily challenges, but has some different ways that it will pull across the data types. Example, we've learned that Kafka and Debezium will pull across a native MS SQL datetime into a string, into the ingest/landing zone. We don't want that. We want proper data types. So we are in our staging layer, casting that back into a datetime and doing that sort of stuff in our stage layer. And that is in the DBT project we've named Curate. After it is staged, then we have a DBT project and corresponding GCP project called Wrangle. That's where the heavy lifting of transformation sits. So again, we're going after global manufacturing analytics here. We are unioning across each of the 3 sites' data and the raw table. So kind of consider it as a staging layer 2.0. If there's a like table in each of the manufacturing sites, it's selecting the data from site number 1, union site number 2, union site number 3, and then soon, when Ireland gets here, site number 4. So bring all that data together in one collective kind of staging 2.0, if you will. And then, as you can imagine, lots and lots of joins after that to get the true transformations that folks are looking forward to consume downstream. Presentation layer, there's dashboards, there's visualizations, reporting, and interest in ML/AI. We're here to enable that type of activity and see how far we can get with the AI activity ourselves as well. But we're really serving other teams kind of in a federated type model for others to consume the data and use and leverage how they see fit. And again, we have you're good. We have a variety of different tools that are that folks are using to consume the data. Excuse me. So a little bit more information here about the project itself, now that we have a landscape of our tooling. Excuse me. We identified tables, as Dan said, there was hundreds of tables that we needed to, from a technology standpoint, enable for replication over into our cloud. So when that was done and enabling CDC and some other configs on-prem, excuse me, we landed the data in the raw in step 3 there, loading it one for one into BigQuery and landing the data from those tables. And then in the curate layer, again, the classic staging type stuff, deduping, filtering, indexing, and casting data types as we see fit. And in the Wrangle, we are unioning like data and doing the heavy transformation layers there. So you can see where DBT fits in and going from steps 3, 4, and 5, DBT doing the heavy lifting with the transformation layer. And then a little bit of a timeline about how we put together this project and implemented. So just over a year ago, last September, we kicked off this project with Dan and I doing the heavy lifting on the back end and doing some of the technical implementations. In November, we had completed some of the initial activity for extracting and loading some of the data. And we called phase 1 complete in January of this year. And then notice a gap between phase 1 complete and phase 2 kickoff. Excuse me. We kind of identified some lessons learned, identified some patterns that we wanted to repeat, kind of turned some dials using incremental models, using micro-badging, and just fine-tuning how we wanted things to run between that January and April timeline. And then notice how quick we went from April 25 to July of calling phase 2 complete. Excuse me. It took us quite a while to establish, get folks trained up, and complete phase 1. But then after we had all those different rhythms established, we had phase 2 kick off and phase 2 complete in pretty short order there.
Yeah, so I'm going to talk about some of the benefits and improvements we realized just from moving our analytical environment from on-prem SQL to BigQuery with dbt. So to be honest, I was kind of skeptical at first. I knew that there was so much complexity. This, with the manufacturing data is highly relational. There is a lot of back and forth with the operational database, and we were doing some pretty crazy stuff in SQL Server, and I was like, how is this going to work with just SQL statements? But it did, and I actually just started using dbt last year, and I'm very happy with it so far. I don't think I want to go back to SSIS after using it. Anyways, the main things I would say would be time savings. I'm estimating like about an 80% reduction in development time to deploy a new fact table to production based on what we had before with our SSIS project. The reload scenarios became much less painful. With on-prem SQL, you're limited to whatever that server, however powerful that server is. With you can add as much, only so much RAM, so much CPU. With BigQuery, you can scale out horizontally and not be constrained by the SQL instance. So these reload scenarios where we had billion row tables would take days and weeks whenever we found a bug or a change in business logic, or they added a new piece of data that we wanted to add into the data model, or we forgot to add a piece of data that they now want. So it was just very meticulous reload, and not only did we have to keep the data live in that table, we had to kind of have a separate work stream to reload to backfill that data. So that became much easier to do with dbt and BigQuery. There's the GitHub version control. It is a much easier learning curve to bring somebody into the project now who knows SQL rather than trying to get them up to speed on SSIS, because that can be very complex. So just easier onboarding, and then overall, our data quality is improved because now we've got one kind of standard method of getting data in one place and having all the raw data there globally and putting them all into common data models globally. We've been able to create kind of a full picture view of each device as it goes through the manufacturing steps, all the way from the subcomponents at the CMs all the way to when we put it into cartons ready to sell. So it's allowed our data science team to have a full picture view of everything and try to find correlations between all the pieces of data rather than spending their time trying to string together all these disparate data sources. And then the last huge benefit I would say is just the visibility with data lineage that's available in BigQuery and then also in the dbt project. You can see where a table was sourced from without having to open up a huge SSIS project and digging through stored procedures, functions, views. That was a very meticulous, time-consuming task before. And then with our YAML metadata, descriptions of the tables and columns, and then just the overall monitoring of runtimes versus monitoring SSIS. So lessons learned, real quick, I have 4 things, kind of highlights. There was a ton of things that we learned, but the biggest things, we initially launched our extract load with Kafka because we had an in-house Kafka team. This was that team's first time working with SQL Server as a source. And so they used a Debezium connector to SQL Server. We discovered early on that when the connector starts up, it actually locks schema by default, which is kind of a problem when you're 24/7 manufacturing, and you can't have more than 30 seconds of downtime on that database without stations timing out. So we did actually, unfortunately, bring down production in Malaysia when we started up trying to load their data. We thought we were safe because we had read committed snapshot on that database. However, the startup process locks schema when it reads it. So you have to kind of pay attention to the configurations. There's a snapshot isolation mode configuration that we dug through documentation and found why it had that behavior. So just something to be aware of. The next thing that we were happy we did, what Roy talked about, we unioned in all the sites data who had like schema, basically union tables together before we transformed anything. So instead of transforming each site on its own, we unioned tables and then transformed, and there's a really helpful DBT macro union relations that you can just write select star, and if there's mismatched columns, it handles that. If we deploy new code to one database and it's not going to happen on the other database till tomorrow or next week, we don't have to worry about explicitly writing out all the columns. So that was nice to find that. One of the biggest things that I found was just dealing with a change in mindset with operational SQL Server. We used a lot of table functions and correlated queries and used cross-apply. Cross-apply doesn't even exist in BigQuery, at least I'm not aware of it. So we kind of had to shift our mindset from, and we were doing that because we were doing row by row aggregation on other data sets. Had to shift our mindset and take those data sets and pre-aggregate them as intermediate steps in order to join to later on. So that was kind of some re-engineering. We tried to do a lift and shift, but it didn't work exactly. That was one of the big things that we had to kind of re-engineer. And then the last thing was incremental predicates with BigQuery tables. By default, when you load into BigQuery, when you merge, it will full scan the target table unless you put a filter on the target. So we learned how to put incremental predicates on the project level and then override them on individual models where we knew that it was write-only data and we didn't have to look back as far. And then we actually had some tables where late arriving data was a kind of a common scenario, and like months ago data would be updated. And so we came up with a situation where we had to create a macro for a dynamic incremental predicate that looks at incoming data and then puts the predicate filter on the target table based on what's going to be merged in. So.
All right, so some pain points resolved. So on the left side there is the legacy on-premise pain points, as Dan mentioned some, and on the right side, we're on the modern data stack and how some of those pain points are resolved. So as Dan mentioned, the SSI package was large. Dan mentioned it himself, even as he wrote most of the logic there, a struggle for him to really understand and comprehend everything that's going on, especially if you start talking about like column for column and column level lineage. Well, now we have that complexity is being resolved by an easy, seamless onboarding process of, hey, there's SQL statements, there's a DAG, there's a visual that's available for us here. Scalability, as Dan mentioned, there's on-premise is not incredibly scalable as you're conflicted with your limits of CPUs and RAM, et cetera. Whereas in BigQuery or name your backend server here, it's scalable. You can increase your Snowflake warehouse size. You can throw more slots at the BigQuery compute engine or whatever the like terminology would be for whatever your backend is. It's scalable. Push some buttons, pay some more money, and then it's faster. It's magic. The visibility, as I mentioned just a moment ago, the DAG, column level lineage, the catalog, it's wonderful. GitHub with the version control, looking at history rather than just saving or creating and replacing a stored procedure on-prem. It's much, much more visible and able to see the history and the change and how things evolve over time using GitHub. Conformity, we have a single source of truth now. We've discovered some things in the manufacturing landscapes, Mesa, Arizona, and San Diego, and Malaysia, and then again, soon Ireland. Having them all talk and having a single source of truth, or maybe like different metrics are defined differently in each place. Well, now we have from a high level, C-suite type of scenario, we have one source of truth and where analytics is happening in one platform. So there's a lot of value to, especially the higher ups in the business from that standpoint. So next, where are we going? I like to say that analytics is never done. We've completed phase 1, we've completed phase 2. Who knows how many phases we're going to have. We're always turning the dials and seeing how current the data needs to be. There's folks that say, hey, I need the data streamed in. I need it to be live or correct as of 5 minutes ago. Maybe they do, maybe they don't. Have the conversation. Let's challenge that. We've had in this past year, we've had folks say, I needed to see the data as it was 15 minutes ago. So your whole pipeline needs to be current within 15 minutes. And we challenge that and then realize they only need about a day or so. So they only need recency in the pipelines to be updated about a day cadence. So there's a lot of technology choices we can make according to the SLAs of what folks need who are consuming this data. So we're continuously improving and further defining SLAs. Again, Ireland is coming on board. We'll have these types of discussions and getting them into this realm of this global manufacturing data suite. And then, of course, we're enabling AI and ML and other teams at Dexcom with this data. And that is it.
Any questions?
Yeah, so with manufacturing, let me give you this mic. With manufacturing, I can imagine there's a fair amount of concern about like a machine breaks or a process like a part comes out deformed, and there's a lot of like alerting and like operational analytics for like making sure that the machines are doing what they're supposed to do. Can you talk a little bit to like where that lives in your system? Like, do you guys own that? Do the operational teams own that? And then like when something breaks, what is the process for alerting, for triage?
Yeah, I mean, that's a good question. We're still working that out. We've definitely kind of grown very, very quickly and had to get up to speed quickly. Right now, I talked about our on-premise data warehouse. That's still in use because it's a little bit more real time. We're trying to get people moved over to BigQuery. Our data science team is fully on BigQuery off of the data we provide there. I would say it's a work in progress right now. A lot of times they'll find issues with let's say a certain like a subcomponent or supplier, and they'll want to go look at the data with all of everything that happened with that part, the parts that use that subcomponent. And I guess I don't know if that answers your question. Maybe.
I can expand a little bit.
Yeah.
So this is analytics that we're trying to solve. That's a problem we're trying to solve for here. We're still having the conversation. Actually, we were just talking about it some this morning. There's a fine line between operational decisions based on data and analytics. Are we trying to make operational decisions? Like there's a tech stack here. And in that pipeline, if any one thing breaks, if you're making operational decisions based off that data, what do? So, me talking, my director's right here, maybe he'll come slap me. For me, like, for on-premise still has a component here. There's the server that's hopefully in like that space in the manufacturing plant inside those four walls. There's not necessarily like a global like architecture that has to be alive and working in order to make operational decisions. So there's a lot at play and a lot to be considered for operational decisions versus analytics for what has happened in the past and trying to make decisions about the future. Does that make sense? I don't think I answered your question, but I gave you a lot to think about.
Hello.
Question?
Okay. Here. So congratulations on moving to the modern data stack. Hopefully you are enjoying. I have a question in terms of the architecture. So you share 3 different tools to ingest the data. Could you expand more on that decision? Because why not choosing only one?
You want to take this? Or?
Oh, I guess I do. So Fivetran, for us, Fivetran was already doing some extracting and loading for some of the data we needed. So we weren't going to disrupt that. That was already live. It was identified to use like the Kafka and Debezium product because there was already a team of experts to do that. They were new to the Debezium portion, and he spoke about some of the lessons learned for Debezium. But for the large scale of data we were using, we identified that as one of our solutions as well. And then,
so the Fivetran, there's a constraint with Fivetran. It basically owns the. If you're going to use it to move data, you can't have. We have Rubric on our production databases, and those 2 things are incompatible. Also, if you want to have any other replication to any other databases from your production servers, then you can't use Fivetran. So that was a constraint, which is why we had to go with Kafka.
And then most recently, we've chosen to start with DataStream because it's an easy button as well. And it's inside the GCP platform, and we're inside the GCP using BigQuery and a host of other solutions inside the the Google platform as well. So it is a little bit of a sprawl, but we're finding success despite our madness.
Yeah, and we're trying to go back and rework and try to put everything on data stream, just the quick and easy. I mean, all we're doing is taking data from one place and putting it in BigQuery. We don't necessarily need a huge Kafka implementation, so we're trying to refactor that. So.
Cool. We're actually out of time, so if you have any other questions, I think the guys have to get going and we'll have to close down the room in a minute. Right. But if we want to take one more quick question and then wrap up, you
Sure.
guys choose. There were a few hands. I don't want to choose for you.
There's one behind you.
Okay.
Yeah, so I saw JUMP as one of the analytics tools on your starting architecture, and I didn't see it afterwards. I'm curious about like the built-in statistics in JUMP that are really, really good and how those are being handled since they're hard to replicate in Tableau. And if your data science team is replicating them, or if JUMP is still being used, just didn't make the slide, or how that works.
We're in the process, I think, of trying to get people off of JUMP and into some of the cloud tools that we have with BigQuery. And that's the short answer. So.
Okay, guys, thank you so much.
Thank you.